So I'm going to start this with what is a mole. A mole is an amount. It is similar to a dozen or a bushel. It is a amount of anything. Usually, it's an amount of atoms, really, in chemistry. It's an amount of atoms. So if you take it, for example, you can have a dozen eggs, and they may weigh 2 pounds, we'll say. And you can also have a dozen of quail eggs. It's the same amount, but it'll weigh half a pound. So it's the same amount, but it weighs less, and that is a big definition of what a mole is. So following that, all of these, this number here, see that on all the atoms? That is all a mole of that atom, which is 6.022 times 10 to the 23rd atoms, which is a lot of atoms. But you can see with hydrogen, it's that many atoms, and it basically only weighs 1 gram. These are all grams per mole. If you go down here to uniquadium, I think that's how you say it, it's going to weigh 285 grams per mole. Same amount of atoms, just one is lighter and one is heavier. Just to show how large a number a mole is, this is how it is. Like I said earlier, it's 6.022 times 10 to the 23rd. And for reference, that is 6.022 times 10 and 23 zeros. So, once you can know the grams per mole of atoms, you can then figure out how many atoms are in something like this. This is a ring of pure gold. If you put it on here, you can see there it's going to weigh 4 grams. So, you take this, it has 4 grams. We go on the periodic table and look for that. Gold is AU, and it weighs 197 grams per mole. So, if we go to the board, you get 4 grams of AU, gold, 4 grams of AU, and that is going to be times by 1 mole over 197 grams. To solve a problem like this, you go 4, just like the weight of our ring, times 1 divided by the weight of gold, grams per mole, is 197. It's going to equal 0.02. So we have our amount of moles, which is 0.02, which is a little less than a full mole, well, a fair amount less than a full mole. So if we want to convert this to atoms, this is our moles. Now we're converting this to atoms, so we're going to do 0.02 times 6.022 times 10 to the 23rd, which is our avogadro's number. And this is going to be over 1 mole. This is our atoms. Our moles will cancel out. And then it's left to the calculator. So on the calculator, we would do this like this. So you have our calculation here is going to be 0.02, and this is going to be times 6.022 times 10 to the 23rd, which is our Avogadro's number, 0.022 times 10 to the 23rd. And then there is more with the 1, but it won't change anything in the equation. So just hit the equal sign here. That gives us 1.2044 times 10 to the 22nd. And one last thing to understand, if you have H2O, it's the same exact thing, just instead of doing the atoms separately, you do them added together. So you have 2 hydrogens and 1 oxygen. So this would be 16 is 1 oxygen, and this is 2. So that's 18 instead of doing 2 1s and a 16.